Okay, in this video I'm asked to graph the inequality y is less than or equal to 3 halves times open absolute value x plus 4 closed absolute value. The first thing I need to do is identify the vertex and recall that the vertex is hk, where the x component of the vertex is h and the y component of the vertex is k, and I need to treat this like positive 4 and flip its signs because that's what this negative h reminds me to do. So this is x plus 4. So I'm going to treat this like the number positive 4, flip its sign to get the x component of the vertex, and that's negative 4. Now there isn't a number being added out here. Well, there is technically. That number is 0 plus 0. Because anything plus 0 will just remain the same. That's the additive identity. So I know that this is really the same thing as plus 0. So my y component of the vertex is 0. Okay, so let's go there. Negative 4, 0. Now I need to determine the slope of my right-hand branch, and to do that I'll look at a. In this case a is 3 halves, so my slope of my right-hand branch is 3 over 2. So I go up 3, 1, 2, 3, and over 2, 1, 2. And then I repeat the process, up 3, 1, 2, 3, over 2, 1, 2. Now the slope of my left-hand branch is exactly the opposite. It's negative 3 halves. So I'm going to go up 3 again, 1, 2, 3, but this time over to the left 2, 1, 2. I'm going to repeat that process, 1, 2, 3, over the left, 1, 2. Okay, and you'll notice the axis of symmetry is right along this line, x equals negative 4. We're not going to note that for now, but I do need to decide if the line connecting these points is going to be solid or dotted. Now since it's less than or equal to, that tells me the equal to part tells me it needs to be a solid line. This part right here is what indicates to me that the line I'm about to connect these dots with is going to be solid. So I'm going to try to draw a straight line through these 3 points the best I can. Okay. And there we go. Now, I still need to shade, and I need to decide whether to shade above the absolute value, that would be in this region, or below the absolute value, that'd be in this region. Well, this is y is less than or equal to, so I need to shade below the absolute value. So I start on the absolute value and I just shade below it. That's down here. So all this region, all of this gets shaded underneath the absolute value. So the solutions to this inequality is the region I've shaded and the actual absolute value graph, the actual graph of the absolute value. Okay, let's identify some solutions. Is negative 4, 0 a solution? So negative 4, 0 is the vertex. And in this case, since I used a solid line to outline this absolute value, that means that negative 4, 0 is a solution because it's on the solid line. What about negative 1, 1? Negative 1, 1 is right here. That's in the shaded region, so this is a solution. About negative 4, 10. Negative 4, 10 is up here in the unshaded region, so this is not a solution. What about negative 2, 3? Negative 2, 3 is right here on the graph of the absolute value, and since it's a solid line, that means that this is a solution. Okay, we've just graphed this absolute value inequality.